In this video, we're going to talk about the ArrayList class. And we're familiar with the ArrayList class. It's part of the Java API. And we're already pretty good at using that. We've been using that for the last few weeks. It's a really useful class that's in there. And sometimes I've noticed that students think that the useful classes in the Java API are somehow like magical, like they must be so complicated that we would never be able to write them as Computer Science 220 students. And that's simply not true. A lot of them have basic functionality in there, and it's actually things that are in our wheelhouse that we would be able to write from scratch if we wanted to. Now, of course, the people who wrote the standard library have made sure that everything's really well tested and optimized and efficient so that we get the best performance out of the code that's in the Java API. So we're going to spend this week working on our own version of the Java ArrayList class, but we're just doing that to kind of peek behind the scenes and discover what it would be like to implement something like the ArrayList class. If in a future semester you're supposed to create a variable sized list that holds objects, you should absolutely use the one that's in the Java API, not the one that we're going to write together this week. Again, this is just allowing us to kind of like peek behind the curtain and also to practice our class creation skills. So far, you've made two classes, the student class and also the movie class. Those have been the last few weeks of lecture, and also the labs that we've been working on. Those are container objects that store information about like a bundle of related data. And that's one kind of class. Another kind of class is something that allows us to organize lots of information, and that's going to be like the array class that we write. It's going to allow us to, just like the array list, store a collection of items that have a reference data type and to process the information in the list in an organized way. So let's think about the array list as a black box view. We've used the array list that's in the API. Super useful because we can use it to store a collection of related data. And it allows us to do things like add an item. It allows us to get the value of a particular index within the list. So we can say like, look at my list dot get, and then give it an index like I, and then it'll return the value that's stored at that position. That's really useful. We know it also has searches built in there, things like the contains and the index of methods. And it also has ways that allow us to figure out how many total items are currently in the list. And that can be really useful as we're processing collections of items. So the API creates this black box view where we don't need to know like what specific algorithm the creators of the contains method used. We just need to know that the contains method will return a true false value, whether the list contains a particular value or not. So again, the black box view is just saying that for all the different methods that are part of the class, we just need to know what inputs required and what outputs expected. We don't have to know all the internal details. Now, of course, if we're the creators of the class, then we have to know the internal details because we're responsible for those. But as just a user of the class, we don't have to know the internal details. So this week, as we're writing our own version of the ArrayList class, we'll like peek behind the scenes and we'll see what kind of algorithms are inside the black box. Again, just to demystify it and make sure that you know that it's not like super complicated stuff beyond your comprehension. Just you don't have to like go down to that low level and understand it every time you're going to use the array list. So our first step as a creator of a new abstract data type is always to think about the data type that we're creating. So we're going to be creating this list data type. And so our first kind of step towards writing that is to think through some design decisions. So we want to write down some information about the data type that represents a list. So I want you to pause the video and think about what would the essential data be? What would the essential data be in a list data type? And then also think about, like, if you were trying to create a list that was used in lots of different contexts, what kind of information or what kind of methods would you make available to somebody who wanted to use that list class? So pause the video for a few minutes, jot down your ideas. Again, you're trying to think about what data would be enclosed inside that class. What do you want to encapsulate in there as data fields? And then also think about what kind of operations would be important for the list so that you could use it. If you want to get inspiration, you can absolutely reference the ArrayList class. That might give you some ideas. After you jot your ideas down, then unpause the video and come back. So there's lots of different possible solutions. This is going to be one possible solution. We're going to use this as our model as we create our list class. The essential data that we would need to have for our list data type includes an array of values. Arrays are really the only way that we know to store a collection of items outside the ArrayList class. And since we're trying to make something that operates like the ArrayList class, we don't want to use the ArrayList class. So we're going to use an array as the behind-the-scenes data storage mechanism that allows us to store a list of items. And then you remember that arrays have to have a maximum size, so we'll also need to know what's the maximum number of items that can be in our collection. And you might not have anticipated that because you might have anticipated that we were making something more exactly like the ArrayList class, where you don't necessarily need a maximum number of items. So if you didn't think of that, don't beat yourself up about it. But we are going to include that in our data type that we create. And then we're also going to need to know the actual number of items that are in the collection, because when we create our array, we might not fill it all up immediately. We might create an array that has the potential to store 100 items, but we might only put stuff in the first 10 spaces. So we might end up with 90 spaces empty. So we'll need to know, like, where's the end of the good data within our collection. Let's turn our attention now to what kind of operations we'd want to be able to perform on the list. So if you use the ArrayList as inspiration, you probably got a pretty good start here. One thing we'll want to be able to do is create a new list object. And of course, we'll be able to do that by creating a constructor. We'll want to be able to find the actual number of items that are stored in the list at any particular time. That'll be useful. That'll be kind of like the size or the length method. We'll want to be able to add a new value to the list, similar to the add method that's part of the ArrayList class. We'll want to be able to return the value stored in the list at any particular position. So that'll be like the get method that's part of ArrayList. We'll want to be able to search the list to see if it contains a specific value. And it's our call. We could write that like the contains method, or we could write it like the index of method that's part of the ArrayList class. We might also want to be able to test to see if two lists contain the same information using the equals method that we learned about last week. And we might want to be able to convert the list into a string representation for debugging purposes. That'll require us to override the toString method that we learned about last week. There's lots of other methods that we could have included in here. Of course, you know that in the real ArrayList class that's in the API, there are many, many, many more methods that are useful. But we're going to focus on just these 7 methods as we implement our version of the ArrayList class. It'll give us a fantastic start, and again, it'll give us insight and appreciation into how the ArrayList class works behind the scenes.